We will go back to the slide, but you have the slides already. So you have the data set here. It's a linearly inseparable data set. We have two features, x1 and x2. If you will use x1 and x2 for solving this problem, it will be impossible to use a perceptron or linear logistic regression. And in this case, you need to work a little bit with the feature construction. So instead of working with x1 and x2, we can introduce a new feature, x3, which is x1 square and x2 square. x1 square and x2 square maybe it will help us to get a decision boundary, which is a circle. All data points which are inside the circle, it will be classified as 1. All data points which are outside the circle, it will be classified as 0. So this new feature, we can just say that it's a super feature. This super feature will help us to classify. This super feature will help us to classify this complex problem. It will help us to generate a complex decision boundary, which will solve the problem. And it's the same for it's the same also for the XOR problem. We can take the XOR problem as like a home assignment today also. So the XOR problem, this is a truth table of the XOR problem. When we draw it like this one, we have 4 points, 2 classes, and it's impossible to find a line which can, not a line, but we can find a complex boundary also, decision boundary. So maybe you can find something like this one. But to generate this one, in fact, you need to use maybe feed-forward neural network to generate this one. So you just need to generate a data set like XOR, and when you plot it in X1 and X2, it will look like this one. So we have 2 classes, and of course it's impossible to find a straight line which can divide it into 2 different separate classes. One way to get around it, we can just use some feature construction techniques. We can plot the data with against X1 and X1 times X2. When we plot it against X1 and against X2, it will be separable. This is the X1 value here, which is positive, times this positive value, so it will be positive, which means this part will remain in that place. So we will have this part here. Here, for example, X1 it's positive, negative, and X2 it's positive. So positive times a negative, so it will be negative. So this class, it will move below X1 here, so it will be in that place. Here, for example, this one it's a negative times a negative, so it will be positive. So that part, this cluster, it will move above X1. This one here, it's positive. This one here, it's negative. So positive times negative, so it will stay negative. So it will stay below. So X1 and X2, it will be negative here. So this is negative. This is positive. Yes, and this is. So when you multiply X1 by X2, so it will be positive times a negative. So it will be negative here, negative X1, X2. And when it's X1 is negative and X2 is negative, so negative times a negative, so it will be positive. So it will be not positive X1 and X2, so it will stay here in that part. So in this case, the data set will be separable. And in this case, we can just use a perceptron for classifying it using X1 as an input and X1 times X2 as a second input. So this one will be here. We will have here omega 1, we will have here omega 2. So in this case, we will create a decision line. So maybe it will be this, horizontal line, right? We will get this. We will get this line here as a decision line. So please try to implement this problem in Colab and share your solution with me and upload the decision line. We need to see how the decision line will look like. So you can also use, for example, instead of using X1 and X1 times X2, you can just expand set of inputs. You will have X1, you will have X2, you will have X1 times X2, and try to plot it. And we will see what is the value of omega 1, what is the value of omega 2, what is the value of omega 3. So we will see if the perceptron will manage to get this line. And in this case, of course, X2 will be 0. So x2 will be 0, so omega 2 will be 0. So we will see. We need to check those numbers. So just please try to generate this data set which looks like XOR, and try to use a perceptron or adaptive linear unit, for example, or just, I mean, use a perceptron or a regression for solving it. Linear regression for solving it. So do you have any question for this linearly separable data sets? Yeah. So we will try to fit logistic regression. So in this case, when we try to fit logistic regression, just imagine that omega 1 equals 0 and omega 2 equals 0, and omega 3, for example, equal 1. So what will be remaining? It's this equation, right? What will be remaining is this equation. And this equation, it is the equation of a circle. This equation, it's the equation of a circle. So in this case, the decision boundary will be a circle. So we will generate a circle where points are which are located inside, it will be one class. Points which are located outside, it will be the other class. So in fact, we have also a data set which called it's called, I guess, circle. I mean, you can generate this data set by also, it's a standard data set which can be generated from sklearn. You can just generate it also, and you can control also how much overlap. So it's by default, it's 2 classes, and you can decide how much noise. But I'm using it here for I did it for Iris dataset, but I mean this dataset you can get, it's called non-separable dataset. So we have a file here which is called a non-separable dataset, because it's also a toy dataset which we can generate from sklearn. So I will try to open this file. It's called non-separable. Yes, non-separable dataset. Yes. So in fact, we have, if you can see my, we have this make circles. It's one of the toy datasets which we can, I mean, generator, which we can generate from sklearn. So generate data. So you have X and Y. You have the number of samples and noise. So for example, how many samples you want to generate and the noise. It will be 2 classes. By default, it's 2 classes. So make circles. You can just, I don't know if you can make 3, but we need to check it, please. If we can generate, for example, 3 circles, or I don't know. Is it possible to use this one for multi-class classification, right? So it's a question. So this is the amount of noise, and this amount of noise will control how much overlap between those circles, how much overlap you want to get. So I just generated this one from sklearn, and plotting it, you will get this graph. And after that, I will use a logistic regression for. So now, for example, I have the features. I mean, the first feature, it's x1, x2. Now I'm selecting x3 equal x1 square plus x2 square. When plotting it in 3-dimensional space, it will look like this one. Now I want to fit a logistic regression. So if you want to include this one, if you want to introduce a new feature, higher order feature. So now I can just say introducing higher order feature. I mean, having this higher order feature, in fact, it can make life much easier, because when we plot the data in 3-dimensional space, we can see that now it's linearly separable, right? We will use a regression model. We will fit X and Y into this regression model, and we will calculate the coefficient. We have 3, if you can see here, we have 3 inputs. So this, it's omega 1 times x1, omega 2 x2, and this one is omega 3 times x1 square plus omega 2 square. And this is the bias value. And I just used it for predicting, I mean, for prediction, and the error is 0, in fact, which means it's 100% accurate. But you can play with a noise value to see if the accuracy will stay 100% or not. So I can generate the decision line. So the decision line also, if I have x1 and x2, I can find x3 using this simple equation, for example. And I can generate this, this plane, decision plane, which separates the two different classes. So using higher order features, it's a very good advantage because it can make life really very easy. But of course, there are some optimization algorithms which are used for finding those higher order features, which we need to find the best set of features which can describe my data set better. So it's a different area which is called feature engineering, and in this feature engineering, feature construction is very important one. Feature construction, we use the actual features for generating new features which can be used for solving the problem. Yes. Are you tired? Do you want to take a break or something? Do you need a break? I guess we forgot to take more breaks today. Yes. Okay. So we can take yes, 10 minutes break, for example, and after the break, we will continue with, we have this logistic regression for Iris dataset. You can try to, after the break, we will just talk about this logistic regression. How can we implement it step by step? So I implemented it here also, and also we can use it from sklearn. We can use it for Iris dataset when it's binary classification, and after that we will go to the confusion matrix. If we have time today, we will try to talk about confusion matrix. So we can take 10 minutes break, and we can meet again at maybe at 2.
Ibrahim?
Yeah?
How long are you planning to keep on lecturing today?
It should be until 2, maybe 2:15, for example. We can stop anytime if you feel that it's enough amount for today. We can.
The sun is shining and the weather is.
Oh, it's
nice,
good.
Huh?
Yeah, we need to go for swimming today, right?
Yeah.
Okay. So
Okay,
should we finish at? Should we finish now, for example, and we can start next time with the confusion matrix, because it's a new part, in fact, which we need to focus on, and we need to just repeat. Use some classification problems and use the confusion matrix for evaluating models. So should we stop here today, for example, and start next week from the confusion matrix?
I wouldn't mind that.
Okay. So okay, guys. So we will stop here today, and next time we will start. We will go from, just remember, please. Next time we will start from maybe just talking about regression model. How can we implement it step by step? I did that here also in this example. So logistic regression implementation, I implemented it step by step. And we can use the one which we implemented for classifying Iris dataset as a binary classification problem. And after that, we can go for the confusion matrix. But please remember the home assignment. It's not the home assignment. It's just this XOR problem, please. Just try to work with the XOR problem and try to work with feature construction. So instead of using x1 and x2, we will use x1 and x2 and x1 times x2, for example, and we will see if we can use a perceptron for classifying it. So, and we will stop here today because really it's sunny today, and maybe you should go outside, try to eat outside, barbecue, and maybe swimming. I went for swimming yesterday, in fact, for 30 minutes. It was very good. So the temperature was 15, but it was great. So I wish also to do it again today as well. So we can stop here today, and we will meet again next week. And from today to next week, please, if you have any questions, just send me your questions. And maybe we will have another, maybe more 2 weeks or 3 weeks in this machine learning part, because I feel it's more important. So we will see how far we can go. And after that, we will work with the expert system part. But I need to give more weight and more time for the, the machine learning part in that course, because this is a part maybe which you will use in your project. So if you don't have any questions, we can stop here today, and you can just take a long break from now until next week. Yes. Thank you very much for today. Any question before you leave? I guess people are leaving quickly. Yes. Thanks for today. Thank you very much.